So I bet you're all wondering why the CPU is a honey badger. You all remember last year's meme, right? The honey badger. Do you remember the tagline of the honey badger? Did you all? Okay, well, the basic line is, everybody who knows it, are you ready? The honey badger don't care. The honey badger, here's an example of a honey badger. This is actually a regular badger. The honey badger is much more badass. The honey badger, like, eats snakes. And, like, all the poison in the snake goes into the honey badger and he just takes a nap. And then he wakes up again and he keeps eating the snake. There's a YouTube video. It's great. You guys have to see it. Anyway, if you don't believe me, go to YouTube and then you will learn and you will agree that the honey badger is a badass. Okay, the honey badger don't care. The CPU is a honey badger. What do I mean by that? I mean that the CPU doesn't care about your fancy objects. The CPU doesn't care about your closures. The CPU doesn't even care about your function names or your variable names. It's all ones and zeros and memory addresses to the CPU. All it wants to do is eat your code and spit it out and go and get the next code, right? Just wants to eat the snake. The CPU doesn't care about how pretty your code is. It doesn't care about how many tests you have. It doesn't care how much refactoring you've done. It doesn't care that you're a pair programmer. It doesn't care. It just wants to eat the code. Or eat the data and run the code, or whatever it's doing. It's just doing what it does. It's just a CPU. It's all ones and zeros. All the stuff that I'm teaching you is about abstractions in order to make your code make sense to humans. Hopefully including yourself, but also including other humans. So abstractions are what programming is all about. Some of you know this already, some of you might be new to programming or might be coming to programming after a long absence or whatever. I'm going to give you some ideology. Given that we are all using computers who are honey badgers who don't care, what is all this abstraction good for? And I'm going to start at a low level of abstraction and hopefully build a few more levels on top of that until we get up to objects. And you'll see that we're adding complexity, but we're also adding simplicity along the way. As we add more and more abstractions, as we get abstracted away from registers and bits and memory, right? Just addresses and stuff. And we get into objects and closures and callbacks and all these things, we're getting further and further away from what the CPU is actually doing. And hopefully, when we get there, our code is easier to understand. It's more concise, it's more elegant, it's easier to maintain, it's easier to share, it's easier to debug when something goes wrong. So now, let me go back and start building up a few levels of abstraction in this little cosmology that I'm specifying here. So at a very low level, one of the most basic abstractions that we do as programmers is we define variables. If you think about it, a variable is a name for a piece of data. The CPU doesn't need that data to have a name. For the CPU to do its job, all that data needs is a location in memory. It's just a number pointing to another number. All right? It's all numbers. Thanks to von Neumann, who figured out that code and data can share the same memory. Awesome. But according to the CPU, it's just a number pointing to a number. For us, in order for it to make sense to us, it has to have a name. And so that's one reason why I'm kind of obsessive about the names of my variables, and why I think that the best refactoring is actually rename. If you have a variable x, maybe that variable should be called sum, or maybe it should be called total, or maybe it should be called numerator, or whatever it is, whatever it's doing inside of your algorithm, you should name it after that. Because then when I come in and read your code, I'm going to understand what it's doing. The CPU doesn't care. CPU don't care, it's a honey badger. It's just going to eat your code and spit it out and go on to the next code. But for me, I'm a human, I care what your variables are named. I care I even care that your code is indented properly. CPU totally doesn't care about that. That's just extra white space to the CPU. It's just going to gobble that up. Okay, let's go up a tier. So we have variables with names. Let's give algorithms names. In other words, functions, right? A function is more advanced than a jump, right? In CPU land, there's no such thing as a function. There's just a jump. We're chugging along, doing this, doing that, doing that. We hit a jump, and suddenly we're doing this and doing that and doing that, We've moved to a new location in memory, and now we're doing that stuff instead of this stuff. But by abstracting it into a function, we give that new stuff a name, that new algorithm a name. We also give it input and output, which is also very useful. It consolidates the problem. It makes the problem for us more easy to understand. There's a discrete point of entry and a point of exit. So that's why I think one of the other most important refactorings, right, probably after rename variable, is extract method or extract function, which means that if we have 80 lines of code, if we take 8 and put them in a function and give it a name, that is awesome, because it means I've now got 10 times fewer lines of code, well, 90% fewer lines of code, right, to worry about. I can understand, I can wrap my head around what those 8 lines are doing with discrete input and output, rather than what 80 lines of code are doing. So if I turn 80 lines of code into 10 8-line functions, it's a really big win. So I like to extract methods or extract functions from code. That's really useful. Again, Honeybadger don't care. It's actually just extra work for the CPU to manage jumping in and jumping out again, to push the variables onto the stack and then pop them off again and all that stuff. But that's what we need it to do for it to make sense for us. Let's add another tier. Closures. Closures are like functions. They have input, they have names, they have input, they have output, and they have operations, right? Stuff that they do. But closures have extra stuff. In addition to input and output, they have scope. So a closure has a little bit of more context to what it's doing, other than just the parameters. Here is where we start to get into the trade-off area. This level of abstraction is sometimes good, but it's sometimes bad. Now that we can pull scope along with us, we can have problems like memory leaks and namespace collision. So watch out. This is good, but it's also possibly bad. It has trade-offs. Does that make sense? We're building up abstraction. We go from variables to functions to closures, and now to objects. An object is kind of like a closure. It's pretty different, but the idea of a closure is to take one function and give it a little bit of context. The idea of an object is to take a bunch of context and give it a bunch of functions attached to that context. An object is a collection of data and a collection of methods that act on that data and only on that data. If you design your objects correctly, you have linked together data and behavior, state and functions, right? Link them together in a way that's sort of like the closures did, but in a much more well-encapsulated way. And where you're really trying to exclude that, just like a function was trying to exclude everything except the input and the output. An object is grouping together related functions and excluding everything but the parameters to the function and the instance variables to the object. Everything else in the world goes away when I'm focusing on that. And again, this is so that your code makes sense to humans. Hopefully it makes your code easier to maintain, easier to debug, easier to share. And if it doesn't, then don't do it, right? If a particular abstraction isn't pulling its weight, get rid of it. Now hopefully you will figure out a way to make objects pull their weight, because I think they're awesome. But there are a lot of people who just make things into objects and make it overly complicated. A particular thing that they were trying to solve, a particular problem, could well have been solved with a function rather than an object. And so maybe that object was too much. You get trade-offs. Objects are, by definition, more complicated than functions. So maybe that extra complexity wasn't worth the cost, wasn't worth the benefits you get. So then finally, to wrap up this whole lecture, we went from variables to functions to closures, which we get a little scope, objects, which get a little more context, and then classes. And I want to make this very clear. A lot of people, when they learn about objects, they learn about classes on the first day or the first hour, right? Like, what is an object? Oh, it's about inheritance. No. An object is about collecting data and behavior. Classes are about sharing behavior between different objects. So if I have a string over here and a string over there, because they have the same class, that means these two separate strings have the same methods, but they don't have the same data. Again, it's more complicated, and sometimes it's not worth the trouble. Sometimes it's better to just make an instance and then add methods to that instance, because you're never going to use those methods for anything else. And in fact, when we learn about objects a little later, we're going to start off with just instances that have behaviors and no classes. We're then going to get into classes after that and share the behavior among different instances, just with a simple thing. But again, if an abstraction isn't pulling its weight, get rid of it. The CPU doesn't care. It's just about the humans. You have to make the decision. Code is art. It's about elegance and abstraction and aesthetics. It's a creative activity. It is not about just mechanically following the best practices and design patterns of the day. It's about you figuring out, like, how do I best express myself in code? How do I take this concept and make it be a recipe that other people can follow? Okay?